Hi guys, let's look at this question. This question says that Ajay intended to travel a certain distance at a uniform speed. Okay. But after traveling for exactly 1 hour, he increased his speed by 25 percentage. Now, since I'm looking at 25 percentage is 1 by 4, let me assume his usual speed is, let's say, 4s kilometers per hour. Okay. As a result of this, the remaining part of the time that he had originally planned for the journey, he ended up covering as much distance as the total distance that he had initially planned, thereby overshooting his intended distance of travel. What is the time taken for the entire journey that Ajay made? Okay. Now, since there was an originally planned time, it's very much advisable to take the time as, let's say, 4t. You can take any value. We can also take t here. So I'm taking 40. Why did I take time? Because I know that the original distance that was planned is speed into time. That is 4s into 40, which will give you, let's say, 16 into st was the original distance planned. Now, when he traveled for 1 hour, and the question says as a part of the remaining part of the time. So the remaining part of the time means he actually traveled at 40 minus 1 hours. Clear? And for this much of time, he increased the speed by 25 percentage, which means if the speed was 4s and increased by 25 percentage, which means he has traveled this distance at 5s. Clear? And this distance traveled is equal to the original distance that he has planned. Now, the original distance that he had planned is 16 into s into t. So if I simplify, this becomes 20 st minus 5s is equal to 16 st. Or what do we get? We get 4st is equal to 5s, or we get the value of t is equal to 5 by 4. Clear? Now, our job is not to calculate the value of t. We initially planned the entire journey to be of 40 hours. So that becomes 4 into 5 by 4, which will give me 5 hours was the initial plan with which this person had traveled. So if you have an option to go with multiplication part, it's advisable to take time and speed, and rather than going ahead with the time taken here, right? So because why am I saying this? Because a lot of students start assuming the distance as d and they go ahead with d by speed is equal to time and so on, so on, so on, which might take slightly more time. So this question I would say was a mixture of simple equations majorly and speed, time and distance. And if you are good at both of them, I don't think so. We should be taking anything more than 60 to 90 seconds to answer this question. So I hope you found this video helpful, guys. Happy learning. Thank you.